Okay. So in the last class we have studied the work energy equation and impulse momentum equation. So now we will move on to the impact of elastic bodies. Okay, take it down. A collision between two bodies is said to be impact if the bodies are in contact for a short interval of time. For a short interval of time and exert a large force on each other during this short period. During this short period. On impact, the bodies deform. The bodies deform first and then recover due to elastic properties. Due to elastic property and due to elastic properties and start moving with different velocities. Different velocities. The velocity with which they separate depends on depends not only on their velocity, of approach, but also on the shape, size, elastic property, and line of impact. Okay. So first of all, you should know what is impact. Impact means it is a collision between the two bodies. The collision between the two bodies is said to be impact if the bodies are in contact for a short interval of time and exert a large force. A large force is acting on a short interval of time is called as impact. Okay, like your atom bomb, blasting of atom bomb. Okay, large force is releasing in a short interval of time. Like you are hitting a cricket ball. Okay, ball is coming and hitting the bat. Okay, that is only short time, but the impact is very high. Okay, that is called as impact. Collision means okay, that is collide, collision between the two bodies. Okay, when the two bodies are come in contact with each other, that entire is called as collision. Okay, collision means one body and another body struck each other. That is collision. This large force releasing a short interval of time is called as impact. Okay, this impact, on impact, the body is deformed first. Okay, see, this is one large body. Okay, this is one small body. They will combine, they will collide each other. Okay, when they collide each other, the bodies get deformed. Okay, body shape will change. Okay, they get deform first and then they recover due to the elastic properties. See, we are dealing with the elastic bodies. As it is having the elastic properties, they will get recover. You take a cricket ball. So it is a plastic, okay, rubber. There is elastic material. So whenever you hit the cricket to the wall, it will get deformed first. Okay. First it will get deformed and afterwards it is going to recover its deformation. That entire is called as impact. Okay, first it is deformed and then recover due to the elastic properties and start moving with a different velocity. This is coming with the u1 and this is coming to the u2 velocity. After impact, they will move away. Okay, which velocity? v1 and v2. But initial velocity and final velocity are different. Okay. The velocity with which they separate depends not only on their initial velocities, whatever they are approaching. Okay, these are the initial velocities. It is not only depending on this one, but also it is depending on the shape, size, and elastic properties, and also line of impact. Okay, these all are the terms. So in the multiple choice questions, he may give. So the velocity of the separation is not as that of the velocity of the approach because of, okay, option A, shape, option B, size, option C, elastic properties, option D, line of impact, option E, all. What is the option? All is the option. Is it clear, all of you?
Yes, sir.
Yes. So now we will study what is line of impact. Okay, we will study some of the technical terms which are important for your exam. Technical terms, or definitions. First one, line of impact. Line of impact. Line of impact. See, this is one body. Okay, and I will take another body. This is one body. When these bodies will come in contact, okay, so this plane is called as plane of impact. This is plane of impact. This is plane of impact, and this is the line of impact. Okay, line of impact. So this is plane of impact. Plane of impact, and this is line of impact. Line of impact. That's the definition. Line of impact. Common normal to the colliding surface, to the colliding surface, common normal to the colliding surface is known as line of impact. Line of impact. Okay, this is one body, this is one body. These two bodies are coming and they contact each other. Okay, so this entire line is called as plane of compact. And the line which is normal to the plane of compact is called as line of impact. Roll number 1, please switch off your phone. Okay, so this is line of impact. So take down second one. Direct impact. Direct impact. Madhura, please mute your
Yes, sir.
video. Video is on. Okay, so direct impact. if the motion of the two colliding bodies colliding bodies is directed along the line of impact line of impact the impact is said to be direct impact direct impact okay. So this is one body and this is another body. Okay, so both are coming and they are hitting to each other, and this is called as direct impact. This is one line, the four bodies coming in this direction, and this is coming in. So the bodies are coming towards each other, and this is as that of the line of impact. So this is the example for the direct impact. Next, oblique impact. Third one. So these definitions are important for examination. Oblique impact. If the motion of one or both the colliding bodies, if the motion of one or both of the colliding bodies is not directed along the line of impact the impact is known as oblique impact. It is not exactly opposite. Okay, it may not be in the line of impact. Okay, so I'll give the example. See, this is one body and this is one more body. Okay, so they are coming in contact with each other, but how they are coming, that is important. This is the body is one body is coming in this direction. Okay, another body is coming in this direction, but the line of impact, how it is? The line of impact is this is the line of impact, correct now? So one body is coming in this direction, another body is coming in this direction. Is this direction is the same as that of the line of impact? No, this is called a oblique impact. Maybe there may be a chance one body is coming in this direction and another body may be coming in this direction. So now I will take this is an example. One body is coming in this direction and another body is coming in this direction. And how will be the line of impact? It is exactly horizontal is the line of impact. Okay, so this is the difference between the direct impact and the line of impact. So in the direct impact, so your motion of the body and the impact line of impact are same direction. Okay, but in the oblique impact, the motion of the body and the line of impact are not each other. Okay, they are away from each other. Yes, always. Whenever two bodies are in impact, okay, that is normal to the plane. Okay, so here what I have taken is this is okay in this direction. Okay, this is a plane. Okay, the normal to this plane is called as line of impact. Okay. Are you getting the difference between the direct impact and the oblique impact, all of you?
Yes, sir.
Yes. Next one. So just take down the figures also so that you can remember very well. Next, fourth one, central impact. Central impact. If the mass centers, of colliding bodies, of colliding bodies, are on the line of impact, line of impact, the impact is called as as central impact. Central impact. See the definition. No, this is one body, and I'm taking this is one more body. No, if they meet each other, okay, they are meeting like this. There is a line, okay, impact. So first of all, I'll take the central impact. They are they come and collide like this. Okay, so the line of impact is our. This is the plane of impact, vertical line. Okay, how will be the line of impact? This is the line of impact. Okay,
Yes.
their mass centers. What he is saying? He is saying their mass centers should lie on the line of impact. This is the center of the mass center of this body, and this is the mass center of this body. Correct? These two are on the same line as that of the your line of impact. Okay, so this is line of impact. Line of impact. Line of impact, and these are the mass centers. Okay, both are on the same center. This is M1 and this is M2. If the mass centers of the colliding bodies are on the same line of impact, are on the line of impact, then the impact is called as central impact. So here you may take it is a solid body or same object also. You can take same object. Okay, this is one object and this is one more object of the same object. Same. So here is also their mass centers are lying on same line. This is the center of the first body. This is the center of the second body. Their mass centers are lying on the same line of impact. Okay. Next, fifth one, eccentric impact. Eccentric impact. Eccentric impact. Even if mass centers of one, even if mass center of one of the colliding bodies is not on the line of impact. The impact is called as eccentric impact. Eccentric impact. So we can take this as example. Okay. This is one and this is one. So how will be the line of impact? This is the plane. Okay, this is the plane of the impact. Correct? The normal to this one. So normal to this was exactly this is the line of impact, and this is the line of impact. This is now the center of the first body is is on the line of impact, but the center of the second body is it on the line of impact? No. Then it is called as eccentric impact. Is it clear, all of you?
Yes, sir.
Next point, coefficient of restitution, which is important, very, very important for your exam point. During the collision, the colliding bodies initially undergo a deformation for a small time interval and then recover the deformation in a further small time interval small interval of time further small interval of time. So the period of collision the period of collision inside the bracket, or time of impact consists of maximum deformation condition and the instant of separation of bodies No. So the period of collision or time of impact consists of two time intervals. Just a minute. There is changeover. Consist of okay. Just take there is changeover. Make a correction. So the period of collision or time of impact consists of two time intervals. Make a changes. Two time intervals. That is period of deformation and period of restitution. Okay. See, this is one body and this is another body. Okay. This body is moving, think that this is moving in this direction, this is moving in this direction. They will come and collide each other. Okay. So that collision will be there only small interval of time. Okay, in that small interval of time, they will undergo maximum deformation. Okay, and again in the small interval of time, they will again separate and they will move away. Okay, so this entire collision, there is two periods. First period is called as the time of deformation, and second one is called time of restitution. First, you should know what is the time of deformation and what is the time of restitution. Time or nothing but period of deformation and period of restitution. After knowing these two, you will come to know the what is coefficient of restitution. So first, you write down period of deformation. First, period of deformation. Period of deformation. It is the time elapsed. It is the time elapsed. Time elapsed means time taken. Time elapsed between the instant of the initial contact of the initial contact and instant of maximum deformation. Maximum deformation. Maximum deformation of bodies. Of the bodies. Okay. So what is the period of deformation? It is the time taken or time elapsed between the instant of the initial contact when the two bodies will come in contact from that time to maximum deformation. So maximum deformation is called as period of deformation. Next, second one, period of restitution. Period of restitution. Restitution. It is the time elapsed between. It is the time elapsed between the instant of maximum deformation, the instant of maximum deformation condition and the instant of separation of bodies okay. So when the two bodies will come in contact with each other, from the contact to the maximum deformation they will undergo. So that period is called as period of deformation. Again, after the maximum deformation, they will get separated. Okay, the time taken between the maximum deformation to the separation is called as what? That is the time of or period of restitution. Is this these two timings are clear, everyone? Is this too clear, Sabiko?
Yes, sir.
Yes. Have you written?
Yes, sir.
Okay. So next line. Hence, impulse during deformation. Hence, impulse during deformation. What is impulse? What is the formula? Impulse formula. F into dt. Yes. Okay. Hence, impulse during the deformation is equal to. I will take instead of F, I will take it as Fd into dt. Where Fd is the force that acts during the period of deformation. during the period of deformation. Period of deformation. Magnitude of FD. Magnitude of FD varies from 0 at the instant 0 at the instant contact 0 at the instant contact to the maximum to the maximum value at the instant of maximum deformation. Maximum deformation. Okay. So what is impulse? That is the FD into dt. FD is the force that acts during the period of deformation. Magnitude of FD varies from 0 to instant at the contact to the maximum value at the instant of maximum deformation. Okay. Similarly, impulse during restitution. Impulse during restitution is equal to FR into dt. Where FR is the force that acts during the period of restitution. During the period of restitution. Okay. So take down some examples for the direction. Now you have to tell me which type of impact it is. Direct impact. Direct and one more point I want. Direct and central. Yes, correct. Okay. So this is direct. All of you write down. Direct and direct central impact. Direct central impact. What this line? This is coming with the velocity u1. This is coming with the velocity u2. They will contact each other. What is this line is called as? Line of impact. Line of impact. Then second one. Which type of impact it is?
Oblique.
U1, this is U2, this is oblique. So in the exam, he may give diagram directly and he will ask which type of impact it is. So you should know. Yes. Now, can you tell me what is C and what is D? Which one direct? C. C is direct.
Direct
Okay.
impact.
Correct. Direct. Is it centric? Central? No, it is not central. What it is
No,
called?
sir.
It is eccentric. 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 This is U1. This is U2. Both are in the same direction. Okay, but their masses are not in the on the line of impact. That's what is called eccentric. Then second one. Which one? This D1. This is oblique because
Oblique impact.
one is in this direction, U2 is in this direction. It is called as oblique. Okay, oblique. Then one more definition. Its masses are is the mass centers are is it on the line of impact? No, that is also called as eccentric. Okay, oblique eccentric impact. Oblique eccentric impact. Have you written? Okay, draw.
Yes, sir.
The online people are faster than you. They have already written. Offline people are still writing. Huh? Syllabus? Oh, okay. पता नहीं. Still, no one has completed. हमारे mechanics ऐसे ही रहते. दो लेक्चर है और दो लेक्चर देखेंगे नेक्स्ट यूएचपी है ना मेनली. Okay, so after completing this one, write on the next line. The magnitude of FR here you have written no? FR is the force of the magnitude of FR varies from maximum from a maximum value at the instant of maximum value at the instant of maximum deformation, instant of maximum deformation condition to zero at the instant of just separation of bodies, instant of just separation of bodies. See the FD values. It varies from 0 to maximum. Correct? 0 to maximum. 0 is at the instant of contact to the maximum at the instant of maximum deformation. And FR, restitution force, that is maximum at the instant of maximum deformation and 0 at the instant of separation. Okay, this value you should know. Completed?
Yes, sir.
Okay. Alright, good. Draw this one. All the bodies are same. So this is before contact impact and this is after impact. Okay. This is a body one, this is a body two, moving with velocities, and this is body one, and this is body two, moving with the same velocity. So body one is moving with the velocity as u1, body two is moving with the velocity is u2, and this is v1, and this is v2. So this is before impact, and this is after impact, after impact, after impact. Let m1 be the mass of first body, m2 be the mass of second body, u1 is the velocity of first body before impact, u2 is the velocity of second body before impact, v1 is the velocity of first body after impact, then v2 is the velocity of the second body after impact. At the instant of maximum deformation, at the instant of maximum deformation, the colliding bodies will have same velocity. Let the velocity of the bodies at the instant of maximum deformation b ud max. Okay, so initially the instant of maximum deformation, the colliding bodies will have the same velocity before, and after collision they will have the maximum deformation they will have the velocity that is ud max. After applying impulse momentum principle, for the first body, yes, the body, what is the force first of all during the time of deformation? FD, time is dt. Okay, so before coming in contact, so what is the velocity of the body? U1. Okay, so the body is having U1. After the deformation, after they are in colliding, okay, when they undergo maximum deformation, that is the maximum deformation, that is the final velocity, correct na? So final velocity is ud max, initial velocity is u1. Then can you write the impulse momentum equation? Yes. So that is f d into dt is equal to, tell me, m1 into ud max, ud max, okay, minus m1 into u1. U1 is the initial velocity. This is final momentum, this is initial momentum. So this is equation number 1. So this can also be written as, so for the another body, or during the restitution period, so Fr is the restitution force into dt is equal to m1 into ud max. Now, see, whenever there is a collision, okay, this is a collision. So when they come in contact with each other, so before the collision, what is the velocity? u1. At the collision, they will undergo maximum velocity ud max, correct? And after the restitution period, so they will undergo v1, correct? So whatever I have applied, impulse momentum equation, this case I have applied up to maximum deformation. Now there is a restitution period from the maximum deformation to till they separate. So you can apply now. So Fr into dt. So what is the final velocity now? v1. Okay. So that is v1. m1 into v1. m1 into v1 minus what is initial? m1 into ud max. This is equation number 2. Is this these two equations are clear, everyone? I am writing for the body 1 impulse momentum equation during period of deformation and during the period of restitution. Okay, you know impulse momentum equation. Force into dt is equal to final momentum minus initial momentum. Okay, for the body 1, so there are two periods. That is period of deformation. Okay, and one more is period of restitution. Okay, first I am applying for the period of deformation. Initial velocity u1 and final velocity in the deformation period ud max. Okay, so m1 into ud max minus m1 into u1. Then in the period of restitution, so maximum is ud max, that is initial for the period of restitution. Then v is the final velocity for the body 1. So m1 into v1 minus m1 into ud max. Is it clear, all of you, these two equations?
Yes, sir.
Yes. Now you can take the ratio of these two. Time over. Okay. So take equation number 1 divided by equation number 2. Now equation number 1 divided by equation number 2. So that is fd into dt divided by fr into dt is equal to m1 ud max minus m1 u1 divided by m1 v1 minus m1 ud max. So this can also be written as fr divided by fr into dt divided by fd into dt is equal to, so m1 I will take the numerator outside and the m1 in the denominator also outside. So what I have written, fr divided by fd, that is nothing but v1 minus ud max divided by ud max minus u1. Is it correct, all of you? Okay, so this is equation number 3. Then similarly, can you apply for the second body?
Yes,
Okay.
sir.
For second body. Okay, apply for the second body. So this equation I will write first. Okay, so for the second body I will write this equation. Yes. So what I will write, fr into dt divided by fd into dt. So during the restitution period, what is will be the maximum velocity? M1
M1
M2
V1.
M2 into UD max, correct? Maximum minus M2
Minus
into
M2
V2 divided by
U2.
M2 into
M2
U2
V2.
minus M2 UD max. M2 into UD max. M2 into UD max. Okay. So this can also be written as, again, take the common, FR divided by FD into dt by dt. Okay, M2 is common. Okay, can I write this one? UD max minus V2 divided by U2 minus UD max. So this equation number 3 and equation number 4 are same. So FR into dt, FD in dt, FD. It means left hand side of this equation and this equation are same. Right hand side is different. So can I equate all these three equations? Okay. So equation number 3 plus equation number 4, equation number 3 and equation number 4 are equal. They are also equal. They are also equal to. They are also equal to the quotient obtained by adding this numerator numerators and denominators we get. See, because just look at the board. See, there is a 9 by 3. There is a 6 by 2. All of you look at this one. 9 by 3 is how much? 3. 6 by 2 is how much? 3. So I will add these two. How much I will get? 6. Now these two, their quotient is same. So I will grab numerators and denominators separately. So 9 plus 6, how much? 15. So then 3 plus 2 is how much? 5. So this is also same. Okay. So this is also giving 3 and it is also giving 3. Okay. So it means when their quotients are same, then we can add the numerators and denominators separately. Okay. So similarly, we can write this one. So this equation is equal to, so in the equation number 3 and equation number 4, so I am adding these two. What is there? V1 minus UD max, and here plus UD max minus V2. UD max get cancelled. V1 minus V2 you will get. Yes, write down that one. All of you write down. So V1 minus UD max plus UD max minus V2 divided by UD max minus U1 plus U2 minus UD max. So this can be written as V1 minus V2 divided by U2 minus U1. Or this can also be written as V2 minus V1 divided by U1 minus U2. So this, what is this one? V2 minus V1 is change in final velocity. So U1 minus V2 is what? Change in initial velocity. So I can write it is relative velocity of separation to relative velocity of approach. So this is called as coefficient of friction. Sorry, coefficient of restitution. This is called as coefficient of restitution. So you can write this one also. Okay, आपको समझ में आएगा. Okay, in the bracket you can write this one.
Sir,
हाँ.
मागची साईड दाखवा जरा.
Okay. ये ना.
Yes.
हाँ. Okay. Roll number 1, 2, 3, 4, 5, 6. Roll number 6. 6 is absent. Eleven, 15, 16, 16, 20, 29, 29, 31, 31, 35, 36, 38, 52, 53, 57, 61, 62, 64. Okay, absent number 6, 16, 29, 31, 36, 53, 57, 62, 64. Okay, so we'll stop now. We'll continue in the next lecture. 7 minutes late. You can come 7 minutes late. Okay. Okay, we'll stop now. Is it over, all of you? Okay, this definition
Yes.
I will write in the next class. Okay, this is a formula. I will write this definition in the next class.